Hey guys, I want to take a few minutes and go over a couple of the problems and with their answers for yesterday's empirical rule handout. We did one in class, so I'm going to start with number 2, which says that given a normal distribution with a mean of 175, so we're going to label that with the notation for mean, x bar, and a standard deviation of 37. That's how that would look. Draw a normal curve and label the standard deviations. So your normal curve is this bell-shaped curve. The mean always goes right in the middle. And then I got a calculator next to me, but the idea is when you add, 137 to 175, you get, this is the position of the first standard deviation. And then if I add 37 again, I get the next standard deviation. And if I add 37 again, I'll get the cutoff for the third standard deviation. And there's a percentages attached to each one of these kind of increments. So if I go the other direction and do 175 minus 37, I get 138. And then minus 37 again. You get, 101, and minus 37 again, 64. And so the empirical rule says that, between these two, you've got 68% of your data. Between these two, you've got 95%. And then between these two, you've got 99.7. And so we're going to be asked questions about percentages. And so for letter A, it says, what percent of values are within 138 to 212? So 138 to 212 is that 68%. That's the answer. Letter B, we've got, that was letter B. This is letter C. What percent falls within 101 to 249? So 101, up here, we're talking about 2 standard deviations. And the name of the rule is 68, 95, 99.7. So the answer to C is actually 95%. I posted a picture on the website, and then, I Googled it just to have access to it. But a similar picture looks like this. And so the idea is if you break them down into chunks, you can start adding these numbers together, which you're going to have to do in a second. If we move on to letter D, it says, what percent of values are between 64 to 286? Again, now we're looking out to 3 standard deviations. And you could add up all the individual pieces, but if it's exactly 3 standard deviations, we have that 99.7%. Letter E, what percent of values are outside of the interval 138 to 212? So this is where it kind of gets a little bit different. So here's the middle, that's what we call the mean. In this case, it's 175. And then the 2 values, it says outside of 138 and 212. Now I know from definition that this is 68%. But this question is asking for what's outside of that, meaning what's the area or the probability of the purple. And so we're going to do a lot of this with in the future, but we know that the whole thing is 100%. That's all the data. So if I want the purple and I minus 68%, I'm going to get 32%, which is the answer to letter E. Letter F says, what percent of values are outside 101 to 249? So same kind of idea as the last one. This is 1 standard deviation, but 101 to 249 is 2 standard deviations. And I know that this entire area inside here, based on the definition, is 95%. And so if I want the area outside of it, aka the area in orange, then I'm going to do 100%, that's the whole thing, minus the area on the inside. And that would give me the area on the outside. So that's the answer to letter F. And then one last one, letter G. What percent are outside 64 to 286? I encourage you to pause it and think about it if you didn't finish this. But if 3 standard deviations now is 99.7, and the decimals do matter, then what's outside of that would be what's in the purple. And that's where you're going to get, 100% minus 99.7%. And you're going to get, 0.3%. A very, very small percentage lies outside. All right, I'm going to do one more question. I'm going to skip 3 because it's kind of like number 2. And let's just give you a guide on number 4. So number 4 says the incubation time for Rhode Island red chicks is normally distributed with a mean of 21 and a standard deviation of 1 day. So it seems like the numbers are nice enough. If 1,000 eggs are being incubated, how many chicks will expect to hatch? So we're going to use a curve. I'm going to set it up real quick. So right in the middle, you guessed it, is 21. And we're actually talking about days. I think it's talking about incubation time. And I like the 1 because it's easy to fill the standard deviations in. I'm going to go in increments of 1. So there's 3 standard deviations to the right. I'm going to go 3 standard deviations to the left. And then I could set up percentages for all these. And so there's one extra step here, but let's take a look at it. Letter A, it says, what's up in 19 to 23 days? So 19 to 23, if we're looking at this, that's 95%. And if the question said what percent of eggs will hatch or whatever it is, the answer would be 95%. But then it added this extra little quirk with 1,000. So we actually need to do 95% of 1,000 to get our answer in terms of the number of eggs. And if we do that, the final answer for letter A would be 950 chicks. So I'm going to do a few more just to get you kind of going on this. For letter B, when it says 21 days or fewer, if 21 is in the middle, then I really want this area, which is half, which is 50%. And so if I do 50% of the 1,000 chicks, well, then you're going to have 500 chicks. Again, if I'm going quick, maybe pause it and let it process for a second. Letter C, it says 19 days or fewer. So 19 days or fewer. Draw a picture, everybody. So I'm going to use the one up here because it's already drawn. Here's the cutoff at 19 days in blue. But if I want fewer, then I want this percentage. You can estimate it right now, for sure it's less than 50%. But, if I break this down, I know that half is 50. I've got 2 standard deviations here, and then my goal is this percentage. And so it would be really nice to know what these 2 kind of missing chunks are. And I honestly don't have them all memorized. I use my resources, but I know this is 34%. And then if I switch over to my cheat sheet, I know that the second one, it looks like, is 13.5%. So I'm going to fill that in here as 13.5. How am I doing on time? Doing okay. And so I know that the goal is going to be 100%, that's everything, minus these 3 chunks. So 100 minus 13.5 minus 34 minus 50 will give my leftovers, which a little deceiving with the picture, but the answer that I got is 2.5%. So a very small percentage. All right, let's do another one. Got a little time left on my clock here. D says in 18 to 24 days. So 18 to 24 is 3 standard deviations. So that'd be 99.7%. And I just realized I didn't convert these last two to chicks. And so when you have 2.5%, I almost made a mistake. This is 25%. So 2.5% would be 0.025 times 1,000 chicks. That would give the actual correct answer. And then 99.7 would be 0.997 times 1,000 chicks. And so in this one we got 997 chicks. That makes sense that almost all of them would be included in 3 standard deviations. And the other one, if I times it by 1,000, the 0.025, it looks like it'd be 25 chicks. A very small chunk. Okay. I'm going to stop there and let you kind of process it. Hopefully that kind of pointed you in the right direction. My big goal overall for all of these questions and almost all the questions moving forward in the class is to, nice and big, draw pictures. They will help you so much. So don't be stubborn. Thanks for watching, and I'll see you guys soon.